we're starting off and they tell us that the velocity function is 1 plus 2t. Now, they also mention something about this position equation. Now, we've used different variables for position. We've used x of t, we've used s of t some, but all of this is the position equation. So if we go from the position to velocity, we're taking the derivative. So if I want to go back from hello.
I just got an email from a 10th grader in the Kenyon's class.
Yes.
She just saw the message about paying the fee. I wanted to know if it was too late.
No,
Check with you.
we need the money.
Okay.
If they've already signed up,
They
because
should-
I've sent everyone's name into the office.
Okay.
Okay.
So, I mean, she's on the list, but she's not paid yet, so that's okay.
Good. Yeah. Thank you. All right. So s of 0 is 0. V of t is 1 plus 2t. So what we want to do here is we want to say, okay, I know that s of t is the antiderivative of v of t. Are y'all with me? All right. So s of t is going to be the antiderivative of 1 plus 2t dt. So s of t is going to be, all right, the antiderivative of 1 is t. 2t would be 2t squared over 2, which would be t squared, and then plus a constant. Now, they give us this, again, this is any family of equations. I'm going to rewrite it as t squared plus t plus c. Just that would be in the form of a quadratic. They're a little bit in descending order. Now, they tell us that, okay, this is a whole family of conditions here, but we know that the initial position is 0 when the time is 0. So I get here, I know the initial position is 0 when the time is 0. So C here would have to equal to 0. So the specific equation for this is that S of t is equal to t squared plus t. Now, a lot of times that C value won't be 0. In this case right here, it's one of the beginning problems, so well, they threw that in there. Is there a question about that? All right, well, let's go with, let's look at question 24. Question 24, and again, if someone would read this is from that same section that the homework was on, 5.1. So question 24, we have what?
Vt equals square root of t plus 3, all in parentheses.
I'm sorry, square root of t
Square root of t
plus
3, all in parentheses 2, not just the square.
okay.
And then to the square root of t. Like
Times?
square, no.
Over
Yeah.
the square root of t. Is that correct?
Yeah.
Okay. And what's my initial condition?
S1 equals 2/3.
Okay. So again, what this is saying is that at time 1, the position is at 2/3. So we're ready to take on the fact that we know that the position function is the antiderivative of the velocity function. I'm going to go ahead and just say that that's the square root of t plus 3 squared over the square root of t dt. All right, so we've got the numerator going here, and that numerator is a binomial squared. So this would be t, and then it would be 6 square roots of t, and then plus 9 all over the square root of t. Are we good here? right, now, again, we've got a monomial in the denominator, and we haven't learned substitution yet. So I'm going to split this up. Are you good? Okay, I'm going to split this up into 3 individual terms. So S of t equals t over the square root of t plus 6 square roots of t over the square root of t plus 9 over the square root of t. And now just reduce it. So t over the square root of t would just be t to the 1/2. 6 square roots of t over square root of t would be what?
6.
Just 6. And 9 over the square root of t would be
9 square root of t minus 9t to the 1/2.
yeah, 9
1/2.
t to the 1/2 power. All right, are we still good here?
Let it be negative 1/2.
Thank you. All right. So this t to the 1/2 becomes t to the 3/2, so it'd be 2/3 t to the 3/2 power plus what here?
6t.
6 times t plus
C.
all right, negative 1/2 plus 1 is
1/2.
positive 1/2. Okay. So it's 9 over 1/2 t to the positive 1/2 plus the constant. Any question there? All right, so the remaining part of cleaning up is really just that third term there. So 9 over 1/2 would be what? 18. So we end up with 2/3 t to the 3/2 plus 6 times t plus 18 t to the 1/2 power plus c. All right, now we have that initial condition. That initial condition says when the time is 1, that the position is at 2/3. So we go over here, we see 2/3 is 2/3 times 1 to the 3/2 power plus 6 times 1 plus 18 times 1 to the 1/2 power. And I know a lot of this you can do in your head, but again, I'm just wanting to, for us to see, okay, where did every term come from here? I went off the screen a little bit there. All right, so 1 to the 3/2 power would be what? Not everyone at once?
2/3.
Wait, yeah, it's just 2/3 left over because that's 1, right? So 2/3 plus
6.
plus
18.
plus c. All right, so I'm gonna pull the 2/3 over here, so it's gonna be 0 equals to 24 plus c. So c is gonna equal to negative 24. So my initial condition that yields that at time 1, my position would be 2/3 is that S of t is equal to 2/3 t to the 3/2 power plus 6t plus 18. I'm gonna put square root of t there. You could put t to the 1/2 if you want to, and then minus 24. So that would give me that initial condition. Is there a question about that one? All right. Now, gonna move on. Look at question 28. Question 28 is a little bit more involved. It asks about the acceleration function. All right? So, what is this equation? A of t equals what?
-2.
-2? All right, what else do they give us?
V of 0 equals 6. And S of 0 equals 10.
All right. Now, we're wanting the initial position equation. That's our ultimate goal here. We want that initial position equation, but we have to start off with this fact that A of t is -2. So what do we know from here? Well, we know that V of t is the antiderivative of A of t dt, because the derivative of velocity is acceleration. So if you start off with acceleration, which we start off with here, its antiderivative is V of t. So V of t equals the antiderivative of -2 dt, which would be that V of t is equal to -2t plus some constant. Everybody okay with that? All right, well, let's continue to work from there. V of t is equal to this, so V of 0 is 6, so 6 equals -2 times 0 plus c, so c is equal to 6. So, with this being my initial position and this being my initial velocity, I'm at the point now where I know that V of t for this specific problem is -2t plus 6. Are we okay with this? Okay, well now we pick up with just like what we've done on the previous two problems here. I know that the antiderivative of position is velocity. No, the derivative of position is velocity. The antiderivative of velocity is position. Said that wrong, I apologize. So S of t is equal to the antiderivative of -2t plus 6 dt. Okay. So, y'all work ahead of me. Did y'all get that? Alrighty. So from here, I know that when time is 0, position is 10, so 10 equals 0 plus 0 plus c, so c is equal to 10. Now, one thing to be careful about, in these initial position problems, when the t is 0, typically all these terms become 0. What you have to look out for, there are two examples that we have to look out for. If S of t has to do with the cosine, well, remember, cosine of 0 is not 0. Cosine of 0 is 1. So when you plug in 0 in a cosine situation, you get 1. So that term won't become 0. And also in the exponential function, if you've got an e to the x in there, and they give you initial position, or e to the t, I should say, and they give you initial time of 0, remember, e to the 0 is 1. So don't automatically think that if this value is 0, that every term becomes 0. Depends on what the function involves right here. So S of t equals -t squared plus 6t, and then plus 10. So if we took the derivative of this, we would come up with this, and if we took the derivative of this, we would come up with this. Are we okay with that?